Good morning, guys. Today, Ari and I are going to talk about one of our side projects, which is building a low-cost data diode. So let's start with a small introduction. My name is Arnaud Souille. I work as a senior consultant at a consulting company called Wavestone in France. I've been doing pen testing and a bit of research for about 6 or 7 years now, and my main interests are Windows Active Directory security and also, of course, ICS security, which is a good thing because the two subjects, they tend to collide nowadays. I've been giving a few talks and security workshops at conference, so you can see at Black Hat Europe, Hack in Paris, BrewCon beside Las Vegas, and at the last DevCon.
Hello, my name is Ari Kokos. I'm also working at Wavestone in France, mainly on audit and advisory, and we often work together with Arnaud on conferences or write a book together. So we'll start with a very few back to basics, just for ICS Security 101, we're just kidding. Just a little reminder on data diode. Data diode is a very simple device with a LED emitting light and a sensor receiving light. The idea behind is that the information is only able to flow physically from one direction to the other and can't go on the other direction. It is very easy to hack electronic software, but physics, it's a bit harder. So why this project? Data diodes exist on the market for more than 20, 30 years, nothing special. I think that during several of our engagements, we saw a need for data diodes, but they were very, very, very expensive. In a lot of cases, the level of security could be really enhanced, but company couldn't afford the device, either because in one case, the cost of the data diode was the security budget for the whole year, or in third world countries where if you buy the data diodes, you are not able to pay your staff. So we saw also a very few cases where there's no need for a data diode with SLA or on a critical system, but just you need to transfer a file. Like in one case, it was for predictive maintenance, just 100 kilobytes every day. You have a window of 6 hours, but if you can't transmit the file on the right schedule, it's not an issue. You can just retransmit. At the end, if it doesn't work, they just take a USB key and send it. In this case, the only part which connected the ICS word and the CURP word was an Ethernet cable to send this little file. In other case, in order to better the process, the company needed to send in real time information from an automated system using Modbus to a third party. And in this case, it meant connecting directly the third party to the industrial world, which is not always a very good idea. So we asked ourselves, would it be possible to do a data diode, and if possible, a very cheap one? There's a lot of work that was done before by Lagardère, Austin Scott, or Robert Gabriel about making a data diode. We see after the basic concept. And what we wanted to do is something really cheap, based on commercial off-the-shelf hardware and open source software. The idea behind is not having like a very complex installation, but having something very simple. You just get the code from GitHub, buy very cheap hardware, and you're ready to run. And one important point, DIODE, we're making consulting, is not a commercial project. It's open source, and it's really open. If there's vendor here in the attendance, you want to use the software to sell it, that's okay for us, and really we really want just to add the community, and it's open at this level. So the basic principle of do your own diode, like we see from years and years, is to have here where the ICS word, here the corporate network. So we just put two gateways in order to transform bidirectional protocols like TCP, where you have to send information in both directions, to a protocol based usually in UDP that just flows in one direction. So here we have an Ethernet connection, and here we have an optical fiber, and then we go back to Ethernet. The basic idea is on an Ethernet to optical converter, you have an input and output, a LED, which sends photon, and a photodiode, which receives photon. So you just connect the output of this box to the input of this one. And in some cases, especially a good fiber converter, they have a link failure detection system, so you just have to put a third one dummy with the input of this one connected to the output of this one, just to bypass the link failure detection. So it's a very basic setup. You can find this in a lot of places in the web, something that works quite well. So what does it look like? It's the box you have just here. If we look inside, here you've got the entry and exit, which in our case is based on Raspberry Pi because it's a very cheap hardware. And here you've got the optical converters with here the output going on the input of this one. Where the two screens, it's not really mandatory, but it's much easier if you want to see some information on the transfer. So, how we did and started the project. The first idea was to have a quick working proof of concept. And here we used a tool called UDP-Cast, which is usually used for satellite communication, where the downlink is very cheap and fast, but the uplink is slow and costly. So there was a feature allowing to send information in a single direction with a lot of nice features like error correction, detection, etc. So we just leverage this functionality of the UDP-Cast tool to send our file from one direction to the other. And then we added a few features that, from what we saw on our field engagement, were really needed. So, of course, basic file transfer, like for updates, antivirus updates, if you have to send files, telemetadata, etc. Also, Modbus. This was one case we encountered in the field. And a third functionality, which is quite useful, is screen sharing. Often you have the support team that needs to access a system, but you don't always want them to have a bidirectional access. However, just explaining by telephone or sending screenshots is not something that is very practical. So the idea here is to have a small script on the computer, on the ICS word. It makes screenshots, and it sends the screenshot to the other side. Like this, there's a video copy, and the technician can follow in real time what's happening on the screen and guide the employee by phone. And then the third and last step was to replace the UDP-Cast implementation used for POC by a custom Python implementation, especially for managing a latency issue, because UDP-Cast is mostly done for telecommunications, so for file transfer it's fine, but if you want near real-time transfer from Modbus or for screen sharing, it wasn't fast enough, so we implemented it. So now, before continuing, we'll start with a demo.
Let's start with the demo. So before going with the video, just want to introduce you our little setup and what it looks like. So the idea during this demonstration is to use the data diode to copy some data, thank you, from the ICS network to the corporate network. That's, let's say, the most common use case. You also have use cases where it's the other way around. For example, if you want to introduce software updates or antivirus updates into the ICS. But in our case that I will show today, the data diode is here and will be used to transfer data from, let's say, one of the supervision workstation to a PC located in the corporate network, for example. So let me also introduce our little setup over here. It's really basic. The idea is to have some kind of traffic light control solution. So here you have two lights that are supposed to be traffic lights. They are controlled by a Schneider PLC. And we also have here a SCADA system. It's a real one. It's IGSS from Schneider also. They have a free version. So we use that to, let's say, have a real SCADA software in our environment. Then, again, here is our data diode, and my PC will be, let's say, the corporate PC that will access data from the ICS. Okay, seems to work. So the first thing I'm going to demonstrate is how to perform a file transfer. So that's quite easy. We wanted to have, let's say, the easiest solution. So here, I'm going to the SCADA PC. Maybe you can not see everything, but I'm going to detail what I'm doing. It's quite simple. I'm copying a file to a network share. There it goes. And a few seconds or a few minutes later, depending on the size of the file, of course, it should appear here on my PC. If it works. Yes, it does. Yeah, so that's the logo from our company. Okay, so that's the basic feature. You copy a file into a network share, and it's automatically copied to the other side. I'm going to deep dive into the details after the demonstration to see how it technically works. Second feature, Modbus transfer. So as you can guess, it's a Schneider PLC, so the SCADA software is sending Modbus request to the PLC to get the state of the traffic lights. Using the data diode, I actually have the same software over here, IGSS from Schneider, and instead of querying the PLC, I'm querying the data diode, and so you should be able to see that there's a small delay between my screen and the reality, but it's about 1.5 seconds, so you have the Modbus data in near real time. Does that work? I'm guessing yes? Yeah, okay. Then the last feature that Ari mentioned is the ability to share your screen. So then again, easiest solution. We have over here just a simple PowerShell script that takes screenshots. And from my corporate network, I will simply go to a web browser and be able, oh, okay, so maybe I need to, yes, so if I move anything over here, for example, I move this window, about 1 second later, the window is going to disappear. So then again, we have a 1 second delay, and you have the impression that you have a video of the screen, but it's actually just 2 screenshots per second. But as you can see, the quality is high enough to read all the errors or debugging messages. So I think this solution can really be used by technicians to be able to remotely debug a problem. Okay. So maybe you have a question, how does it work from a technical point of view? So let me explain that. First thing first, the file transfer. What we do, we copy a file, as mentioned, from this PC to a network share, which is hosted on one of the Raspberry Pi of the data diode. Then what we do is we take the file name, we calculate a checksum, and we send this information to the other Raspberry Pi on the other side. Then we send the actual file, we recalculate the checksum, and if it matches the checksum that we sent earlier, we have the integrity of the file, so the file is copied to the network share on the output side of the data diode. So this way we are sure that there is no error in the file transfer. And then from the corporate network, I can just access the network share. Regarding the Modbus transfer workflow, as mentioned, we do not want to have a direct connection between my corporate PC to the PLC. So how does it work? The input Raspberry from the data diode will have a Modbus client. Every second, it will request some values, coils, registers, from the Modbus PLC. Those values will be serialized, sent over a UDP connection to the output Raspberry of the diode, and on the output Raspberry, we have a Modbus server that will update its value with the one sent by the input counter of the diode. So from the corporate network, I'm actually sending requests to the Raspberry Pi that will act like a PLC. So that's the easiest solution that we find. Last thing, the screen sharing. As mentioned, PowerShell script on the SCADA PC that will send 2 screenshots per second on a network share. Then, again, we send that over a UDP connection to the output counter. And then we use a technique that's used mainly by webcams, I think. It's a web server that serves an mJPEG file. So that means the client sends one request, and then the web server just keeps sending new pictures every 500 milliseconds, which gives the impression of a video. Okay, still on the technical side, this is the configuration file of the diode. We wanted to have something that's easy to configure, so you have, well, a few things about the configuration, like the version. We also have to specify the IP address and the MAC address of the Raspberry Pi, because since we do not have a full duplex connection, we cannot perform standard ARP, so we have to do static ARP. And then for each module, you just input the type. For example, if you want to exchange file, you have a module of type folder, the input folder, the output folder. For the Modbus type, you just have to input the PLC IP address, what kind of registers and coil do you want, and also the output port. Because, for example, if you want to get data from, let's say, 3 PLCs, on the output counter, we're going to instantiate 3 different Modbus servers on different ports. So that's how it works. Finally, the screen type is actually like the folder type, because we are just sending screenshots. Okay, so as Ari mentioned, the goal was to have $200 data diodes, and we failed a bit. I think we can admit that, because the total cost for this model is more like $300 to $400. We only accounted for the Raspberry Pis and the copper optical converters, but actually we had to buy a rack, which is, let's say, the most expensive part on our setup. We added some screens, so yeah, it's a bit more expensive than what we tried to do in the first place. But again, we wanted to, let's say, sell the project, so we know that we had to put it in a rack, because people like to, let's say, stack security appliances. And then we thought we need to go cheaper. Our goal was $200. We have to match that goal. So what did we try to do? First question, why not just using a standard category 5 Ethernet cable and cutting the reception cords or strings inside the cable? Yes, that could be an idea, because you have different strings, 2 for the transmission, 2 for the reception. So actually, if you cut those 2 and you use the half duplex mode, you have a one-way medium. It seems really, really simpler than what we did, and also cheaper. But the problem is, then again, as Ari mentioned, most of the protocol we use on a daily basis are based on TCP. So you need to perform some kind of network translation, because you cannot do the TCP handshake over a cable if you cut the 2 strings. So even if you use the cable, you will still need the Raspberry input and the Raspberry output counters, as well as the code we developed to make it work. So you cannot just use a cable. And then again, from our perspective, an optical connection is really more secure than just Ethernet cable, because some advanced attack, really slow, may be performed over an Ethernet cable, like shutting in, doing a if up, if down, and so that may be used to, let's say, make some data flow from the output to the input. So that's why we stick with the optical connection. Okay, so regarding the improvement, so we took a look at the list of the components, and we saw that the most expensive were the Raspberry Pi and the optical converters. So we tried to replace that. First thing, we replaced the Raspberry Pi, which were Raspberry Pi number 2 or 3, depending on the version, with the Raspberry Pi Zero, which cost only $5. So it's really, really cheap. However, it's not so easy to find. And then, instead of performing some complicated and high-speed stuff with Ethernet optical converters, we had the idea of using a serial connection, so very basic, between the 2 Raspberry Pi, and using a single component integrated circuit called an optocoupler to have this kind of one-way connection. So actually on the down on the slide, you have the schematics from the optocoupler. It's actually one light emitting component and one light receiving component. It's mostly used to isolate from an electrical point of view 2 parts of an electrical circuit. And actually, it works quite well when you want to transmit information. It costs about €2, so that's really cheaper than the optical converters. The bandwidth is, let's say, acceptable. Yeah. Well, on the Raspberry Pi Zero, we have like 4 to 5 kilobytes of bandwidth, so it's not much, but it's really sufficient for Modbus transfer. And if you use a bit more powerful Raspberry Pi, like the latest version, number 3, we can get about 20 kilobytes per second. So it's not that bad for something that costs €2. Of course, and that's our idea, if you work in a very sensitive environment, maybe you will not trust a black box integrated circuit. So it's a better idea to, let's say, create your own directly with all the components. So you buy the photodiode and the LED, and you perform your own kind of circuit. Okay, so let's take a look at the total price. Here we have this new version, version 2 or ultra low cost version for about €80. We still needed to have the USB Ethernet adapter for the Raspberry Pi Zero, which are actually 3 times more expensive than the computer itself. I'm sure you can find cheaper version. We bought ours from Amazon. So on the right, you have small picture of our proof of concept. Of course, now it looks like something like this. So it's really, really small. You can actually put it on a DIN rail, so it's easy to use. We will have that in demo also at the Geek Lounge. And as you can see, we used, we call that again, a logic analyzer that was plugged before and after the optocoupler to see what kind of delay is induced by this component. It's about 10 nanoseconds. The problem is if you want to use a very high-speed serial connection, then the optocoupler will not follow along, and so that's why we have the 20 kilobytes limit at the moment.
So, is a data diode a magical solution? Well, usually data diodes are used in 2 kinds of environments. Classified networks, when you want to have information going through the outside world to the classified network, but never in the other side. And usually, the information flowing from the classified side to the outer world is limited and is manually reviewed. But on an ICS network, you need to send information to the corp world, information about how's working your industrial system. But also, on the other side, you need to get updates, to get PDF files. And at the end, if you don't really build well a security, you tend to have 2 data diodes in 2 opposite directions, which annihilates the benefits. So the aim of our project is just to provide the software and the hardware in an easy way, but you have really to mind the integration, which is a critical part also. Just a short word about the threat modeling. The only thing that guarantees our project is that the information flows in one direction to the other, because based on physical properties, the photons can only go in one direction. However, we also rely on logical and hardware paths, especially the Raspberry Pi, which can be DOSed, or they are not, for now, especially ardent, they can also be hacked and data can be tampered.
Yeah, just one precision. It's actually quite funny. We wrote that, what do we guarantee? That no data will go from out to in. So we do not guarantee that some data will go from in to out. So it may fail, but it will fail safe. That's the whole idea of this device.
Also, what are the current limits of our implementation? For now, our solution is not yet ready for critical system, especially since there is no SLA. If there's an issue, you have to replace it yourself. For now, the 3 main points are performance. We are limited to a few megabytes, so for most of the cases, it's sufficient. But if you want to quickly transfer a few gigabytes, it's not sufficient. But you can, of course, stack several diodes. The second thing, not so much for ICS, but for sensitive network, is there is no tempest protection. The main channel, based on an optical conversion, is quite sure that information cannot flow in the other direction, but you can always use side channel, as one gateway can emit electromagnetic leaks, which can be captured on the other side, which is usually called tempest. Here, what you can do, a very cheap solution, is to buy Faraday cages. So something quite expensive, but in forensics investigation, you have some kind of Faraday bags, which cost between 5 to 30 euros, and at the Raspberry Pi, quite small, you can put a bag for every Raspberry Pi and just have the optical part going from one bag to the other. Like this, you can limit the emission. And the last point is the gateway hardening. For now, we didn't do any specific hardening, but of course, you can apply classical hardening measures such as PAC, such as the Linux, etc., on the gateways in order to enhance the level of security. We'll see after also some other enhancements.
Yeah, and we can also say that we use Raspberry Pis because it's really cheap. But if you already have, let's say, a hardened Linux or a few spare servers, you can really replace the Raspberry Pis by standard rack servers if you want. It's going to be more expensive, but at least you can, let's say, configure it the way you want. So you can reuse actually the same code.
So now we're working on a few improvements, especially on Modbus or S7 that we also want to implement, integrity control. As we get the information from one system and then write a file and send it, we can have a control on the value and then act as an application firewall. Let's say that you have a system that is running at 200 turns per second. If it's going at 250, it will break. So what you can do is set some kind of range, and if the value is outside of the range, the command is not sent. So it acts as a WAF for industrial systems. Of course, we want to implement something very basic, which is a 8-bit system to check that it works. So something very simple. And we also like to work on file integrity, especially to avoid the introduction of malicious code. The very basic thing that we can do is on the receiving side, install an antivirus which will check the file transferred. Well, this works very well if you are based on signature system. Unfortunately, it's quite easy to bypass this kind of antivirus schemes. And what we'd like also is to have something that removes any active code in a file. Here, there's a lot of projects, open source, like Lagadex exefilter, which removes active content like macros, JavaScript, etc. from files. Or things like what did the Luxembourgish CERT, which is to take a PDF file and convert it in images and then have back a PDF file. For binaries, we can also work on hashes or on digital signature. Well, this is the first level, but if the attacker is able to find a vulnerability on the trusted parser, he can execute code and then have persistence on the converting system. So in order to raise a bit the level for the attack, what we can do is use 3 RSPI and 2 diodes. And having so one RSPI, 1 diode, 1 RSPI, 1 diode, and then 1 RSPI. And putting the trusted converting software on the RSPI in the middle. Like this, the attacker can only send information in one direction and he can't receive. So if he's only on one side, it's feasible, but much harder. And then the third level would be to limit the persistence. So instead of using Raspberry Pi, we can use a throwable virtual machine. The idea is when you want to convert a file, you spawn a virtual machine, it makes the conversion, and then it is destroyed. So the persistence is limited to a few seconds. And for this, a very good implementation is Johanna's Cubes. It's an operating system really very well conceived in order to have a segmentation and isolation of different parts, and something that's ready and that's open source. We also would like to implement other protocols to have something working out of the box, SNMP, syslog, Windows Share, etc. And we also want to improve the traceability of the transfer. Something very basic we can do is just having a hash of every file which is sent, of the values of the Modbus stored. But in order to mitigate the risk of modifying these hashes, we can use the same setup as we've seen before, and then having a device in the middle performing the hash calculation and maybe cryptographic signature of this hash, for instance, using an open PGP card. Here in Sweden, you've got Yubico, for instance, which is very cheap and quite a good product. And then the last improvement that we want to do is use our system to transfer files from 2 USB keys. Well, this is something very classical. We just have to replace the Ethernet input by an USB input. And then we can just copy the files in one direction and check the content with the things that we saw before, antiviruses, hash checkers, and even, for instance, if we want to limit the bad USB attacks or something like this, we can use for the gateway in, the gateway out, instead of Raspberry Pi Zero, computer running on cubes, because cubes have a lot of built-in protection in this case. The idea, as Arnaud showed, the small form factor of the device.
Yes. Just watch the cables.
Yeah, here it's done for network, but actually inside it's half of the side. So you can just have something as big as this, and one USB key inside, one on the other, and you can rather safely copy and check files.
Okay.
So what we have at the end, we've got a quite cheap solution. It works. It's open source. So if you want to contribute, really don't hesitate. We'll really appreciate any feedback. If you want to contribute code, please feel free. If you want to review the code, you can go on our GitHub, check, get the code, and test it. So thank you very much. If you have any question.
I think we have seen some questions sent in over the Mentimeter, so if you could please have that up on screen.
Could I have the questions? There we
I think the poll is interesting.
Yeah.
So 67% of the people that answered the poll use data diodes.
Censorship.
Because I don't know what's your opinion on that, but I've worked for 4 to 5 years performing security assessment on ICS. I've never seen a data diode used. So
no, me.
But I think
that's a good thing.
I think the statistics are a bit skewed. There are 3 people at
3
4
people.
So now it's changing quite rapidly.
So what is the? You can still
send
give
in.
your vote there. So
that is a really good poll.
Now it's changing.
Unfortunately.
Okay.
Well, that's why do the vendors charge so much for commercial data diodes? It's simply because they can. Well, for this I have no idea. I have theory, but that at the beginning data diodes were used especially for classified networks. So you had to have certified products, and usually you had one maker in Europe, maybe 2 or 3 in the States. So people didn't have the choice. They needed to use data diode, and there was only one product, so they could have very high prices. But for the industrial world, really, we can't understand, because if you look at the software, it's something very basic. Like, okay, there are some makers that are doing quite a good job with the support of a lot of protocols, like, for instance, direct Oracle copy from one side to the other. They support
OPC.
hundreds of protocols. That's may justify the price. But for instance, in our country, we've got a diode maker, and it's just basically making file transfer, and system is very, very expensive.
Yeah, maybe we can just add that our system is nowhere near the same speed and quality and reliability of a commercial data diodes, but our opinion is that there are a lot of use cases where you do not need that speed. So the commercial products are expensive because they're good, but people should sell cheaper products that go a bit slower. That's our opinion. Yeah, but we do not want to say that we did the same thing as a commercial data diode for a tenth of the price. That's not the idea. The idea is that it's another kind of product.
So, but just a comment on that. So a question. So the price. So what? Maybe you said it before, but what is the typical price range for commercial diode today? Just so people could have a comparison.
It's really complicated to answer because there are some commercial discussions every time.
But in general,
I would say a few dozen thousand euros, depending.
Depending. A very basic one, it can range for 10,000 to 30,000, but after between the public price and the private price, it really depends. But yeah, for something that worth maybe €1,000 of material, they will sell it 10 times the price. Yeah. Plus the support, which is charged separately, of course.
Okay, next question. Is this diode installed in production in live operation somewhere?
Not at the moment. We certainly hope to do so. Actually, in France, there's a cybersecurity agency called the ANSSI that performs certification of some audit and penetration testers. So our company is certified by this agency, and so we have a specific perimeter for very sensitive audits. We hope to use this one, but actually, since we travel the world showing the diode, we have to build a new one.
It's dirty.
But yeah, we hope to build not the new version, but the old one to perform Windows updates from the internet to our sensitive network. That's one of our goals for the next year. Yes, but
that is a really good use case. Windows updates.
Yes, that's the only update we will have at the moment. We are in discussion with some of our clients, but since this is a do-it-yourself product, and most of our clients work in big companies, it's not so easy to, let's say, convince them.
So maybe there is someone here that wants to be a beta tester or guinea pig or pilot. Yeah.
Okay. Is there a roadmap for further development for DiodE?
It's not really a roadmap, it's a list of actions. There's no specific schedule, but it's implement S7 because it's quite used. Then work on file integrity, integration of the protocols, and traceability, which are the main points.
Well, what we would like to do also is make it easier for people to use it, so maybe provide directly Raspberry Pi system images, pre-configured. That's something that, in our opinion, may help spread the product.
So there are coming in some comments on the price there. 15 years ago, we developed verified HTTP DiodE module for commercial firewall. So it's
and then it was like 40,000 euros.
Yeah, that's quite expensive.
The price,
yeah.
Okay, we continue.
It becomes more common to import external data into the ICS, such as GIS data. What are your thoughts about that?
I'm not sure what GIS exactly means.
Geographical information.
Oh, okay. Well, first thing first, you have to sanitize the data that you import, because if you rely on GPS input, it can be faked. So that's first comment. And as Ari mentioned it, most of the time on a big ICS network, you will end up with data diodes in both directions. So you also have to make sure that the way your network is segmented means that the data diodes are actually useful. Because if you just put one in this side, the other on the other side, then the security improvement is not that big. But
usually what you do, you manage this with what is called trusted converters. Like, for instance, if you import CSV files with a specific format, like a GPS coordinates, it's quite easy to write a software that checks that there's only this information that goes inside and no active code. And as I mentioned before, usually what you also need to import is PDF files, like instructions, manuals, and for this you've got quite a lot of software, like what did Jonah in Cubes, the Circle with Circlin, which also works on Raspberry Pi, or Lagadex Exifilter. You have a lot of software like this, but you have to think your security as a whole and not just the stock security appliances.
That's true. How strong is the guarantees for the diode?
well, there is no guarantee. It's an open source project. You can do whatever you want with it. And as mentioned, I'm going to put the slide again because it's really nicely written. Oh, sorry, you didn't see that. Okay, the idea is that the only thing that we guarantee is that no data will go from my computer to the ICS. That's the only thing. We do not guarantee any reliability. We cannot. There's no SLA because we do not sell the product or any kind of support. But the fact that it uses unidirectional optical connection, it's backed by physics. So at the moment, I'm not aware of any kind of attack that can go against a data diode. So that's pretty much secure if you use it correctly. But as mentioned also by Ari, if you do not perform logical hardening on the exposed interface, so the interface that's exposed to the corporate network, you can still get pwned. The information will not go to the ICS, but you can modify on the fly all the data that's transferred. So, but hopefully someone will contribute to the project and make it more reliable or more secure. I do not know.
And as you said, you reach out to people to actually even being vendors and taking it and
yes,
reselling it.
Exactly. And we do not want to brag. The product is not magical, or yeah, it's just a few lines of code that we develop. But if a vendor wants to use the code, you can feel free to do so. But also, what we really hope is that a vendor will get the idea that you can sell a few thousand data diodes if you sell it cheap enough. So that's really our point.
Which has an impact not only in the industrial world, where you can afford data diodes for critical environments, but also in third world countries where in some place they really need data diodes, for instance in the water system, and they just can't afford the software, and there may be lives at stake behind. So if a vendor could have a cheap system, that's something that could really enhance the level of security and safety in these countries.
So that is really what we see here as well. I mean, the premium vendors, no names mentioned, but you know who they are. They are even more expensive than that price tag. And if you are a municipality doing water treatment and stuff like that, there will never be a chance that they will have something like a diode.
They're getting installed in nuclear power plants and stuff
that's
like that.
it.
But there are so many people or organizations and facilities that really need this kind of segmentation.
And also for simple use cases like getting time synchronization or getting logs out or whatever.
Yeah, because at the moment people start to, let's say, centralize all the logs from the corporate network. Sometimes they do also the log from the ICS, and at the moment for this use case, I've never seen a data diode. So yeah, that could be a good idea. Also, if you have, let's say, a security operational center and that you perform log analysis for several clients, it might be a good idea to have a data diode that will prevent an attacker coming from one of your clients to spread across all your clients. So that's also a use case, I think.
So, any more questions?
No, I don't think so. Not here. Do we have there? Okay, there's a message from the other side in the 4.6 forum. Well, if we don't have any other questions here, we will
have them leave the stage and
we have
everything in place so they could go down and set up for the demo.
Exactly.
Yeah.
So feel free to come at the Geek Lounge during lunch, for example. If you want to connect to the data diode, play with it, or if you have some improvement ideas, we will really be glad to hear from you.
Yes. Great.
And there will be a coffee break now.
Yeah, we'll thank you with a big hand.
Yeah. And there will be a coffee break now until 10:30.
And also, remember, there is also coffee in the